Today we are going to discuss about analog communication systems. Myself Sharanya Nivashini from CSE department, Erode Engineering College. First thing is, what is communication? So communication means process of transferring information from one point to another point. That means exchanging information from 2 points, between the 2 points. That is a exchanging information from one point to another point. That is a communication. That is the process by which one information, we are having a one information that is to be a source to destination, one point to another point. We are having one information that is transmitted through the channel. In between we are connecting the transmitter. Information is connected through the transmitter and is transmitted to the channel, and from the channel the information is received by the receiver, and then the destination is achieved. That means the information is from source to destination. In between the channel we are having the noise. That is, noise is added from anywhere. That means an electronic components, or by an information, or by an interference, when some of the signals are transferring in the electromagnetic waves, so that by using these signals in air, lot of signals are transferring. By these signals the information can added into the noise. So by the merging two noises or an information, the noise will be created in the channel, or by any of the electronic components also the noise will be created. That noise source will be added, and with the noise the channel is transmitting the information to the receiver. In receiver part we have the rectifiers or removing the noise filters. Likewise we are having the receivers. So receiver filter all those the noise, then the information, original information can be rectified in, and the destination we can achieve the original information. Next one, the elements of communication systems means, what are the elements? In the information source, message is transmitted from the message or a group of words or codes, data, signals, whatever we can be transmitted. So from this the information source is to be originate in information source. The transmitter, the objective of the transmitter block is to collect the incoming signal or message signal or codes or data, whatever the incoming signal from the information source is collected and then modified to the suitable signals, and then can be transmitted to the channel. What is the working of channel means? It is one of the physical medium. It converts the transmitter information with that of the receiver. That is the only working of the channel. What the physical medium does means, physical medium manufacturing means, that's a copper wire, a coaxial cable, fiber optic cable, whatever it be, is a physical medium. Then what is the receiver working means? Receiver works that receives the information from the channel, what the incoming signal transmitter, that information could be received in the channel. So that informations are received by the receiver only. That recreate information, that means original information is recreated, and then the receiver receives the message signal from the receiver. And what is the signal means? It is a physical quantity, then it is dependent on variables. That means a space or time, lots of signals are available. That is depending upon the time domain representations or a frequency domain representations. In electrical waveforms, it is an electrical waveform that is to be represented as a carrier informations, that is to be as m of t, that is equal to a cos omega t plus y. That pi means phase, then omega means frequency, then a means amplitude or peak amplitude. What are the types of signals available means? Analog or continuous signal and digital signals. There are two types of signals are available. One is the analog and there is a digital. We can transmit the analog signals depending upon our applications. and we can also transmit the signal in digital format that are easily understandable by everyone. So nowadays we are using the digital signals for transmitting lots of informations and easily acceptable by the applications also. The analog signals are also known as a continuous signal. When the amplitude of the signal continuously varies with respect to time, that is known as the analog communications. The signal is to be like that, x of t, and signal is having, this is not a sine waveform, this is just one of the message signal. It contains a low frequency or high frequency, whatever it will be added, and it may be having a noise. We don't know any of that. It is in a low frequency or in a high frequency, just that is a information, that is a message signal only. It is a non-modulated signal also. Then what are the types of signals? First one is a digital signal, next one is a baseband signals. The digital signal means only two discrete amplitudes, that is known as digital signals. That means as one is 0 or 1, that is to be a digital signals. Where the signals are classified into two signals, that is a baseband and also a band pass signals. Baseband signals means the signal contains zero frequency, that is known as baseband signals. That means as example voice, audio, video or biomedical signals. These are the baseband signals. Band pass signal means if the signal contains band of frequency, that means if the signal contains some amount of frequencies, that means a high frequency or low frequency, whatever it would be, that is to be a band pass signals. There are example amplitude modulation and frequency modulation signals. In later we will discuss about the amplitude and frequency modulations. Then what is the message? It is a sequence of symbols, that is a message. What is the information means? It is a content in the message, that is known as the information, that is inversely proportional to the probability of occurrence of the symbols. What is the information means? Information, either we can transmit the information as a bits, bytes or a desert, nats, whatever, that is an information. Informations are measured by using the bits, bytes and nats, and that is also baud rate also mentioned. What is a baud rate means? How the bits, how the messages, how many messages are transmitted from one part to another part, that is a counting is known as the baud rate. What are the limitations? We are having some of the limitations in communication systems. So what are the limitations means? Technological problems. So first thing is technological problems. That means to implement a communication system, that means that we are having three types, right? One is the transmitter and receiver and the channel. These are three components are here which requires hardware only. So and also three hardwares are available. So when we are transmitting information from one part to another part means we need three components, hardware components. That is also complex and also be an expensive. This is the one of the technological problems, right? Then next one is bandwidth and noise. Noise cannot be reduced but also be reduced by using some of the filter methods also. So effect of the noise can be reduced by providing more bandwidth to the stations. Due to this, number of stations cannot be reduced. So this can be accommodated. This is only to be an accommodator. So this is another type of limitations. Next finally is signal to noise ratio. So signal to noise ratio is known as the noise should be low to increase the channel capacity, but it is an unavoidable aspect of a communication system. But whatever we can transmit it or which modulation types of pulse code or digital or analog, whatever it would be, we have some amount of signal to noise ratio, and we have to find and calculate these noise ratios, but we cannot never neglect these types of noises. So what is modulation? Modulation is a very important part in the communication systems. It's a process of varying the characteristics of high frequency carrier in according with instantaneous value of modulating or message or baseband signals. That means we can modulate the low frequency signals to the high frequency signal or a high frequency signal to the low frequency signal. Depending upon our applications, we can change the frequencies. Now, for example, when the input is to be as a voice message or an audio means, if the audio is we don't know when we are applying the when we are transmitting one information in audio means we don't know whether it is be a low frequency or a high frequency, we don't know. When the information is transmitted as practically, we just know transmitter from information to receiver, then that means from source to transmitter we just know how the frequencies it would be. When the frequency is lower means we can add the high pass filters, that means the frequencies would be higher. Then we are giving the input in a high frequency signals means we can add the low pass filters by reducing the frequency level. So these could be equalized by both information source and the transmitter part. This is to be mainly used in the modulation, is used to be in the transmitter part for reducing or increasing the frequency signals. Then when we are having the types of modulations, what are the types of modulations means continuous wave modulation and phase modulation. Now we are going to move on the phase modulations, right. So phase modulations means frequency modulation, amplitude modulation, these are the important types of continuous wave modulations. And in phase modulation, analog modulation, digital modulation. In analog modulations only PAM, PWM and PPM are available. These are the three types of modulations available in analog modulations. So analog modulations PAM, PWM, PPM means when the signal is transmitted in pulse, that way only we can transmit and neglect some of the noise that are created by the interference in the surroundings or in an air space. We can use the PAM, PWM and PPM signals. And when the pulse code modulation and delta modulations mean, here we are having the two noises are occur in the delta modulation, that is to be as a granular noise and slope overload distortion noise. This delta modulation means step size could be increased. When we are increasing the step sizes, these two noises, that means slope overload noise and granular noise, can be rectified by increasing the step size. Step size means when we are giving the one sine wave as an input signal means that could be transmitted as a pulse signal, converted into pulse signals, that the step size will be created. That is depending upon the pulses. Okay, when we are giving the input signal as a sine wave, that is converted into the pulse signal, the size of the steps, that means size of the pulses, is to be as a input signal, right. When now we are going to increase the step size, we are easily neglecting the two noises produced by the transmitters. What are the noises means slope overload noise and granular noise. These are the drawbacks that are occurring in the delta modulations. When in pulse code modulations, these two problems are also neglected. So pulse code modulations is easily transmitting the information from one place to another place without noises. And what are the types of modulations? First one, we are going to talk about the amplitude modulation. So the amplitude modulation means the carrier is varied in according with the instantaneous modulation of modulating signal, that is known as the amplitude modulation. That means the carrier signal, first thing we are giving to the input, that is a modulating signal, and second thing we are giving the carrier signal, that is we act as a track. Then the information signal and carrier signal is multiplied, finally only we get the modulated signal. So the amplitude of the carrier is varied, that is to be known as the amplitude modulation. When the frequency of the carrier signal is varied means that is to be as a frequency modulation. When phase of the carrier is varied means that is to be as a phase modulation. What are the benefits or a need of modulation means? We can reduce the, when we are using the transmitter, antenna is to be used only in the transmitter side, right. Receiver side also we can receiving the information by using the antenna, right. So height of the antenna will be reduced, or length of the antennas is to be reduced by using the modulation, benefits of modulation, and also multiplexing, and also for narrow banding, then we can reduce the noise also. And also there was some of the limitations are available. There is a reduce the size of the equipment or avoid everyday equipment informations. These are the benefits. Now we can clearly seen about the amplitude modulation. What is the amplitude modulation means? Carrier of the amplitude is varied, right? So this is the just to be a baseband signal. Here the this is a one information source, that is to be a input signal, that is a sine wave signal we are giving the input, right. So continuously this is the frequency, so continuously signal is transmitted, there is a carrier signal. So this peak of the amplitude is mentioned as AM and peak of the carrier signals is mentioned as AC. That means C is denoted as a carrier signal and AM is denoted as the modulating signal, that is to be as input signal, or else it is said to be as a baseband signal. Now, what are the outputs? By comparing these two, baseband signal and carrier signal, by comparing, by adding or mixing these two signals, what is the output we received means modulated amplitude signals, that is AM modulated wave. So, finally, this is the outer wave is to be a sine wave and inside of these two waves is to be a carrier signal. Carrier signal is acted to be as a track. The information is to be loaded in the track. The track is travelled from one part to another part. The information is transmitted from one point to another point. As this way, the carrier signal and modulating signal is acted in the amplitude modulated way. So, by adding the two signals AC plus AM, that means carrier signal plus modulating signal. So, carrier signal is denoted by, that is a C of t. In expressions we are to be denoted as C of t, that is equal to AC cos omega C of t. AC means maximum amplitude of the carrier signal and omega, that means we also know as 2 pi f C, that means C is denoted for carrier signal. There is the frequency of carrier signal and the input signal, that is a modulating signal, right, or a baseband signal, that is to be as denoted as X of t. This is an X of t signal and this is a C of t signal. So, X of t is equal to AM cos omega m of t. So, AM means amplitude of the baseband signal. Then next one, S of t. What is the X of t? S of t means amplitude modulated signal. It is denoted as a S of t, that is equal to AC cos 2 pi f of t into 1 plus MA cos 2 pi f m of t. The final expression is denoted as this. Then M of A means, that is to be as modulation index, that is AM divided by AC, that is a modulation index. Next, we can represent the AM waves in two different types. First one is a time domain representation and another way is a frequency domain representation. In time domain representation, first of all we are having the first term carrier signal with amplitude AC and frequency FC. So, first one we are having the upper sideband and lower sideband. Upper sideband means the signal they are having the positive side, that is to be as a upper sideband, and this is the negative side, this is to be as a lower sideband. So, we are having the upper sideband frequency and the lower sideband frequency, and that frequencies we can denote it as the FC plus FM and FC minus FM. In the amplitude, how could we denote it means mu AC by 2 and mu AC by 2. This is to be an amplitude. This amplitude will be a constant and only the frequency will be vary depending upon the sidebands. Next one is frequency domain representation. In frequency domain representation, that is to be expressed is S of t is equal to AC cos 2 pi f C of t into 1 plus MA cos 2 pi f m of t. By taking the Fourier transform on both sides, we can achieve this information. Okay. So, del Fc minus F minus Fc and F minus Fc. So, it is to be mentioned as the upper sideband and lower sidebands. This diagram is known as a spectrum diagram. How could we learned from this diagram means, this is the upper sidebands that we already learned in the sine waveform, right, modulated signals. Okay. So, AM modulated signal we already know that the upper sideband and lower sideband. Here the expression is to be like a triangular wave. This is the spectrum diagram. This is the lower sideband and this is the upper sideband. In lower sideband, that is frequency is to be mentioned as the minus terms, and in upper sideband that is to be mentioned as the plus terms. So, here we are having the x and y axis. this side are the plus terms and this side are the negative sides. So here we have to be as an positive side is to be here and negative side is to be here. So both the sides we are having the between the first x axis and y axis is achieved here. This y axis is to be as a fc and x axis is to be as a frequency. So fc plus omega is the upper sideband, fc minus omega is the lower sideband. Here minus fc plus omega is the lower sideband and here minus fc plus minus omega is the upper sideband. So minus fc to plus fc only we have calculated from this. In between the signals is to be as a 1 by 2 k omega ac into m of o, that is to be as a minus omega to plus omega. Then modulation index, how could we define the expressed as the modulation index means a maximum minus a minimum divided by a maximum plus a minimum, that is to be as a amplitude modulation and carrier, amplitude modulating signal and carrier signal, that is to be mentioned as a modulation index. How could we raise the percentage modulation means the percentage of modulating, percentage of this expression is denoted as a percentage modulation. What are the types of modulation index? There are three cases are available. The first one is modulation index should be less than 1, and the third case is modulation index should be greater than 1, and the second one is modulation index that is to be always equal to 1. When we achieve the full modulated signal means that is to be as MA is also equal to 1. In this position only we can get the exact modulated output. This because of under modulation is a this cannot be achieved a full modulation, right? Then this is the over modulated. When the over modulated means we cannot easily occur the input signals. So this is the critical modulation, that means that is equal to 1, that is to be mentioned as 100% modulation. Here we having one of the diagrams how the expressions, how the waveforms are to be depending upon the expressions means. First the under modulation, MA is less than 1, that means the under modulation, right? MA is less than 1 in first case, MA is less than 1 means AM divided by AC less than 1, okay, or AM less than AC, okay. So when the carrier signal is increased, when the modulating, that means input signal is very low, how could we achieve the modulations? We cannot get the full input, we cannot receive the full message signal in the output. So this cannot be achieved a full modulation, right? In final, when we get over modulated means when the full input signals are, we can achieve the full information, but the carrier signal cannot be received means how could we achieve the full information? So this is also over modulated. For this, when the AM and AC is equal to 1 means we can achieve the full modulated signals because of amplitude modulation is equal to the carrier signals. So carrier signal is also equal. So when we are when input is given to be as an amplitude modulation, the carrier signal is to be constant frequency and amplitude and frequency or levels to be a constant in carrier signal. So finally we can achieve the modulation, so that means modulated signals. Now we can discuss about the how the amplitude modulated wave could be generated. So there are some types of modulators are available. Here the square wave modulator are having this is the modulating signal, that means x of t, that is to be as input signal, and here having the carrier signal, that means EC cos 2 pi fc of t, this is a carrier signal. By mixing these two signals, a non-linear device is available. When you are giving the voltage supply in V1 and V2 to be in between these two signals, the non-linear device is given to the transformer. So this is to be as a, when we are connecting the transformer with the capacitor means this circuit is to be as a tuned circuit. That means we can changing the frequency, carrier levels can be changed, okay. So finally load is to be connected in the final stage. So finally load, from the load we can achieve the modulated signals. So how could we express these signals means when we are connecting the two input signals, that means voltage 1 and voltage 2, that is to be expressed as x of t, that means input signal plus carrier signal. When say voltage 2 carrier signal is already given to be here, and for one input signal x of t and carrier signal, by adding these two signal we can achieve the V1 of t, right. Then V2 of t we can achieve V1 of t, output of V1 of t, and D, that means V1 square of t, that means a non-linear signal, non-linear device signal. So that is to be as equation 2. By using these two equations we can achieve the V2 of t expressions. Next one is how could we achieve the band pass filters. So by output of the band pass filters, by adding these terms, unuseful terms, by eliminating the band pass filters. So we can eliminate the band pass filters for achieving the V out of t. That means a cos 2 pi fc of t plus 2b x of t into a cos 2. The two carrier signals are to be achieved. Next, second method is switching modulator. In switching modulator, we are giving the carrier signals and modulating signal. To these two signals are given only to the V1 of t, and that is to be connected in one of the diode, and that diode is to be connected with the resistor. Finally, we can get the output. This is one type of the modulator. Then how could be the detector? How could we receive these signals? This is the amplitude modulated way. This could be received by the receiver. The finally how the input would be given? One of the sine wave will be given, any of the sine waves, right? Any of the modulating signal. So finally we can achieve the input signal in receiver. So what are the types of AM detectors? Square law detector, envelope detector and rectifier detectors. These are the three types of detectors are available. So when we are giving the amplitude wave is applied to the input of the detector, in every positive half cycle, diode is to be given as a forward bias and capacitor is to be using for a carrier charging purposes, right. Then the capacitor charges to the peak value of input voltage, diode stops conducting. The capacitor discharges means or between the peak charges, right. The process of continuous and carrier capacitor charges and discharges repeatedly, with process could be done. In rectifier detector, diode acts as a rectifier and allows only positive half of the modulating signal. Then low pass filter removes all the high frequency components and that are giving in the envelope output. Then the output rectifier is finally given to the DC 0 value. Then what is the SSB SC signals? We already know the DSB SC signals and SSB XC signals, right. So DSB SC and SSB SC means that means double sideband suppressed carrier and single sideband suppressed carriers. So now we discuss about the double sideband suppressed carrier signals. How could we apply means by multiplying the carrier signal and input modulating signal, that means x of t and cos omega c of t. When we are modulating these two signal, that is to be done by the product modulator, the output is produced as x of t into cos omega c of t, that is to be a modulator. When modulator multiply two signals, that modulator works as a multiplier. So x of t and cos omega of t is the output of DSB SC signal when the signal is to be transmitted by using the antenna. Then it is also having the types. First one is a balance modulator. It consists of two amplitude modulators arranged here. So first one is x of t, and here having the two modulators, that means M1 and M2. Two modulators are available. So one signal is given to the balance modulator directly and another signal is given to the balance modulator 2 in 180 degree phase shift. 180 degree means negative signals. X of t is given to the M1 and minus x of t, that means 180 degree phase shifted output, that means minus x of t is given to the modulator M2, right. Now carrier signal is given both the modulators M1 and M2. So carrier signal is to be a CT. Here how could be expressed means EC cos 2 pi fc of t. Here also EC cos 2 pi fc of t. So these two signals are given to the two balance modulators, right. So this can also be named as a balance modulator or AM modulator. Okay. So first one is given to the output of balance modulator M1 is to be mentioned as S1 of t and output of balance modulator 2 is to be mentioned as the S2 of t. By adding these two signals, that means positive and negative signal, by adding these two signals, the output is to be generated as double sideband suppressed carrier signals, that is to be generated as S of t. S of t is equal to S1 of t plus S2 of t. So, you are having the expressions, right. So, you are already seen in the diagrams. Here it would be expressed as output of balance modulator is 1 m of x of t and carrier signals. So, S of S2 of t is minus x of t and carrier signals. Why two applied signals are given to the subtractor? What is the output? That is the expression we are achieved. Then this is another method as a ring modulator. Ring modulators also having the two types of modes. What that means? Without modulating signal and with modulating signals. Without modulating signal means what is that means? In mode 1, that is C of t is positive and C of t is negative. This is the mode 1 without modulating signal means, right. So, C of t means when the diode is to be connected, we are giving the two diodes, right. One diode is to be connected in a forward bias, another is to be as a reverse bias. Okay. So, first one D1 is to be in stable condition and D2 is to be connected with the forward bias, D3 and D4. Here ring modulator means totally 4 diodes are available. So, first one is to be connected in direct mode and second one is a forward bias, 3 and 4 is to be in reverse bias. In second, C of t is in negative means D1 is to be connected in direct and D2 is to be, now we are connecting the reverse bias and D3 and D4 are now connecting in the forward bias. The output of the ring modulator will always be 0, okay, because it is in a forward bias and also in a positive. Then here it is a reverse bias and also it is to be as a negative. So, that output of the ring modulator will achieve be as 0. Then mode 2 with the modulating signal. So, what we achieve means when the modulating signal is present during the positive half cycle, here having the 4 diode. So, D1 is achieved in the positive half cycle, D2 will be in on condition and the T1 secondary T1 is directly applied to the primary T2. Here we are having the transformers, right. So, first one is D1, D2, D3, D4. When we are connecting the D1 is in stable condition, D2 is to be in forward or reverse, whatever it would be. When the D1 is connected in forward bias, in positive means the output will be 0. When D2 is connected in the negative, that means the reverse bias in negative mode means the output will also be in 0 because of D2 and D3 will say achieved by both in the forward and reverse bias, right. So, transformer is connected here, two transformers are connected T1 and T2, two transformers are connected. So, first the transformer is given to the modulating signal, that means x of t is given to the T1 transformer. So, from the T1 transformer the positive is connected. So, D4 is connected to in between the two points, that means A and D, two nodes in between the D3, D4 is connected and the C and B in between D3 is connected. In the transformer positive and negative in between the connected diode is D2 and transformer negative and transformer another negative point is connected to be with the A, B nodes between D1. The output is to be DSB, SB signals, right. So, first one, now then the x of t is the input signal, okay. So, first x of t is given to AF modulating signal. This is also known as the carrier signal. It is given in the form of pulse signal. We can give whatever, right. So, carrier signal is given. Now, what the signal is to be achieved in the final means when D1 is in on conditions and D2 is also in on condition, D3 is also in on condition and D4 is also in on condition, right. So, how the pulses are to be achieved? This is to be as on condition and here the waveform is to be as an off condition. So, this is mentioned as a T1 and this is mentioned as the T off condition, T on condition, right. So, how the time domain and frequency domains are mentioned means message signal is to be as x of t and carrier signal is to be as C of t. So, by adding these, multiplying these two signals, S of t is achieved. So, by adding these two signals, the multiplying these two signals, the final modulator DSB SC signals can be achieved. So, next one, this coherent detection. How the coherent detections means the S of t, that means the signal waveform DSB SC signal, right. So, DSB SC wave is given to the product modulator, right. Then Here the local oscillator. Local oscillator means it produces the carrier signal continuously, it gives the carrier signals, right. So local oscillator and input modulating signal is given to the product modulator. Output of the product modulator is given to the low pass filter. Wave pass filter is using for the purpose of when the high frequency is signals is having, means when we are reducing the low frequency, we are using the one of the component as low pass filters. So finally we can achieve the output. So generation of SSB SC signals. First of all, we have already learned double sideband suppressed carriers. Now we are going to learn about the single sideband suppressed carriers. So single sideband suppressed carriers also having the three types of methods. So first one is filter method. So filter discrimination method means first also we can give the input signal, that means message signal as M of t, and the carrier signal EC cos 2 pi Fc of t, that is the carrier signal. By multiplying these two signals, that will be produce DSB-SC signal only. From the DSB-SC signal, we are using the band pass filters. From the band pass filter, we can achieve only as SSB-SC signal. We cannot directly achieve this product modulator as SSB-SC signal. What is the working of a band pass filters means? It gives only upper sideband or lower sidebands. Only single sidebands it will be produced. For that purpose only we are using the band pass filters. Next one, second type is phase shift method. In phase shift method, it can also represent as phase discrimination method, right. So first one, X of t, modulating signal is given directly to the modulator, product modulator 1 and product modulator 2. We are giving the 90-degree phase shifter input, that means to be mentioned as X of t. Here it would be mentioned as X cap of t, right. It is also achieved by the Hilbert transform, right. So by the output of product modulator 1 is directly given to the adder and product modulator 2 is directly given to the adder. By adding these two signals, SSB output will be achieved. In between these, carrier signal is given to the product modulator directly, right. X of t and the carrier signal is modulated then given to the adder. Here product modulator 2 cos signal, that means carrier signal is given to the phase shifter, 90-degree phase shifter. So 90-degree phase shifter means in the cos 2 pi Fc of t is directly converted into sin 2 pi Fc of t. So this will be achieved by the product modulator by adding the Hilbert transform, that is to be as X cap of t into Vc sin 2 pi Fm of t. So these two we are adding by the adder, then the output will be produced SSB SC signal, that is as lower sideband signals. Either we can achieve lower sideband or higher upper sidebands. So this is the next modulation type. This is the quadrature amplitude modulation. So the quadrature amplitude modulation is directly given to the as last modulation methods, right. First one M of t is given, that M1 of t is a modulating signal, right. So oscillator always produces the carrier signal, that is to be represented as a cos 2 pi Fc of t is given to the modulator. The output of the modulator is M1 of t into cos 2 pi Fc of t, that is directly given to the adder. Here the 90-degree phase shifter is added to the another balance modulator. So M2 into sin 2 pi Fc of t, this could be modulated, that means balance modulator, then given to the adder. The adder produces the S of t, that means both product modulator 1 output and product modulator 2 output. By adding these two modulated output is given to the S of t. Then S of t is transmitted to the channel. In between the channel is fixed. From the channel we can know the noise is added, any of that, because of here in practical method here we are adding one of the antenna, okay. So in this antenna we can transmit the information, okay. So the information is transmitted in the air medium, right. In air lot of signals are transmitted, so from that signal they can add the noises, okay. So noises or any of the interference or any collisions of out of that noise will be added. So with the noise the channel will be transmit the information from this channel part to the receiver antenna, okay. The antenna of the receiver is received that signal, then only here then the receiver part only we are using the filter methods. In between we can't able to filter any of the noises or any filters we can't able to use, right. So this output is given to the same what are the components we are using in the transmitter block, that components also to be used in the receiver part. So here we are giving the balanced modulator S1 of t and S2 of t is given to the balanced modulator, and the balanced modulator 90-degree phase shift that to be as mentioned as sine, and also oscillator generate carrier signals is given to and create the S1 of t, that is given to the output of the S1 of t is given to the low pass filter. Low pass filter reduces the high frequencies given to the low frequencies, and low pass filter produce the output of S1 of t. Then the S2 of t is given to the low pass filter. The output of the low pass filter is as to be mentioned as M2 of t. Then next one is quadrature amplitude modulation. The output of the transmitter, that is, and these are the expressions that we have achieved in this block diagram, right. So quadrature, and that is by M1 and M2, then that is to be transmitter part. In multiplier S1 and ST is to be multiplied. Finally we are achieving these modulation these expressions, right. In the second and third sums are high frequency signals that are to be eliminated by the low frequencies. So finally M1 of t by 2 is to be achieved from the low pass filter 1, and low pass filter 2 the M2 of 2 by 2 that is to be achieved from low pass filter 2. Finally, what is the frequency modulation? We are up to the last quadrature amplitude modulations. These are all the under the topics from amplitude modulation. Here we are going to see about the frequency modulations. So frequency modulation means the carrier signal of the frequency is only will be varied, otherwise the amplitude is to be in constant, right. We can't able to change any of the amplitude, that is to be as a frequency modulation. So what is the relations between the angle and frequency modulations? Means both are that are same to be a same, okay. When there was lot of differences are not available in these two frequencies, okay, angle and frequencies. So what is the signals we are giving to the frequency modulation means, here also we are always giving to the carrier signal, that is to be mentioned as C of t, that is given to the AC, that is represented as AC cos omega C of t plus pi, that is carrier signal, and pi is to be as phase. Then C of t and phi of t is to be mentioned here, right. Then when we are giving the data signals, and also we are adding the signal into the carrier signals, then modulator is fixed in between these two signals, modulated, these two signals are combined, then finally the output to be expressed as this forms. When the compressed signal is having the high frequency signals, then the signal is to be in expanded form, this is to be as a low frequency signal. In digital form, how could we mention this is to be as 1, and this signal is to be as 0. So here how could we explain means this is 0, 1 and 0. This is the from this way we can achieve in the digital format, right. So how could we express C of t is equal to AC cos omega C of t? Then and also here having the instantaneous frequency. The how could we express the instantaneous frequency means omega high is equal to omega C plus kf and m of t. So kf means it's a sensitivity factor, right. Next one is a phase modulation. What is a phase modulation? By varying the phase of the carrier, that is to be as a phase modulation. So modulating signal is also known as the x of t, always to be represented as x of t, and carrier signal is also to be represented as a C of t. We already known that, right. So amplitude modulating signal means AC cos psi I of t. Then these signals are to be combined with the phase sensitivity, that is to be denoted as Kp. Next one is a deviation ratio. How could be mentioned as a deviation ratio means maximum and the minimum, that are always to be mentioned, right. But here how could be mentioned means modulating index corresponding to the maximum deviation and maximum modulating frequency, that is to be mentioned as a deviation ratio, that is expressed as del max divided by f max. If the FM is broadcasting, the maximum value of deviation is limited to 75 kilohertz means The maximum modulating frequency is limited to 15 kilohertz. Next one is carrier signal. The carrier signal can be represented as EC is equal to EC sin omega c of t into pi. Pi means in phase angle we are represented as a, in phase modulation we are representing as a phase angle, alright. Fc is a carrier frequency and omega c is also known as a angular velocity and E of c is the instantaneous amplitude. And how could we represent the FM wave in to be in a time on a, that means time versus frequency waveform is to be here. The height that means the sine wave the peak of the sine wave is to be as a positive peak, that is to be mentioned as a minus f, and this is a minus plus f, right, plus f and minus f. The height of the amplitude is denoted as the del. Okay. So here how could we represent means f is equal to fc into 1 plus k E m cos omega m of t. Then the maximum deviation del is to be denoted as maximum deviation, that will be given by k into EMFC. The instantaneous amplitude of FM signal is given by EFM is that means EFM is equal to A sin Fm omega c and omega m, that means carrier signal and modulating signal, that is to be denoted as a del, right. So here how could we express this term means here k is be as constant and this is the modulating signal and cos omega c of t is also a modulating signal, right. By integrating these signals we can achieve the omega c of t plus k E m f c omega m of t divided by omega m. Then how could we substitute these equations means we are having the constant factors del is equal to k into EMFC. By applying these constant factors in these equations we can achieve the EFM is equal to A into sin omega c of t plus mf sin omega m of t. This is the equation for frequency modulation. Here having the spectrum diagram. So already we can know the upper sideband, lower sideband spectrum diagrams. Here how could we express means in detail we can seen here. Well, this is the y axis to be mentioned as fc and here the x axis to be mentioned as a frequency, right. When the carrier signal increases the frequency will not be increased, right. This is the number of sidebands are here, upper sidebands and lower sidebands. Here the lower sidebands are to be mentioned in the negative form, upper sidebands are to be in the positive form. The bandwidth of these two signals, that means bandwidth of fc minus fm, fc plus fm, this is the distance is denoted as a bandwidth, that means distance between the two signals, two spectrums is denoted as the bandwidth. So bandwidth is also depending upon some of the rules. What is the rules means Carlson rules. Carlson rules means the bandwidth of FM is twice the sum of deviations and the high frequency modulating signals. That means BW is equal to 2 into del plus FM maximum. The higher order side and lower order side, two sides are available. In here the higher order sides, the modulation index to be mentioned as M is equal to del divided by FM. For example 20 kilohertz divided by 5 kilohertz. From this the bandwidth is to be as what is the formula means BW is equal to 2 FM into highest order sidebands. So 2 into, for example we are giving the FM as 5 kilohertz means into higher order sidebands. So higher order means that is given as a 7. So what will be achieved as the bandwidth means 70 kilohertz by multiplying the 2 into 5 kilohertz into 7, that means higher order sideband. Finally we achieve the 70 kilohertz. This is the example for achieving the bandwidth. So what is the types of frequency modulations available means narrow band frequency modulation and wide band frequency modulation. What is the narrow band frequency, wide band frequency means modulation index is small, that is to be as narrow band frequency. If then the modulation index is large, that is to be as a wide band frequency. Here having one table where the difference comparisons between the narrow band and wide band. So first one, modulation index less than or slightly greater than 1. That is to be as a narrow band. When the greater than 1 means that is to be as a wide band. In Narrowband FM maximum deviation is only as 5 kHz, but in wideband FM 75 kHz deviation will be achieved. Then maximum modulation index is slightly greater than 1 in narrowband FM. In wideband frequency 5 to 2500 maximum modulation index will be achieved. In narrowband FM, bandwidth is to be denoted as BW is equal to 2 FM, but in wideband larger than 15 times in narrowband. So we have to be denoted as BW is equal to 2 into del plus FM maximum, because of narrowband is greater than 15 times, right? So then applications. What are the applications means in narrowband we can use the short range of distances and police, wireless, walkie-talkie, ambulance. We can easily communicate using the narrowband frequency modulation. But in wideband frequency we can broadcast high quality music transmission. For that purpose only we can use the broadcasting wireless wideband frequency modulation. How could we represent the frequency modulation? Means we all already know the time domain frequency representation and frequency domain frequency representation, right? So in time domain representation, how the signals is to be achieved means when the compressed signal is to be as 1 and expanded signal is to be as 0, right? This is depending upon the frequency in time depending upon the time domain, right? Now frequency domain means this is to be achieved by using the spectrum diagram only. Okay, so how to plot these waveforms means Fc plus Fm, Fc minus Fm, then here having the Fm, so here having 2 Fm, 3 Fm. So up to this plus 2 Fm plus 3 Fm, here we can achieve. So here having some of the comparisons between AM and FM. Amplitude of carrier is varied in according with the amplitude of modulating signal, keeping frequency and the phase is to be as constant, right? So in amplitude modulation, carrier signal of the amplitude only varied. In frequency modulation, frequency of the carrier only varied, but the phase is to be is constant. Modulating signal keeping the amplitude and phase signals of the constant. Next, in the constant parameters, what are the parameters that are available in the amplitude modulation means frequency and phase, and in frequency modulation means amplitude and phase. These frequency and phase to be is constant in the amplitude modulation, amplitude and phase to be is to be constant in the frequency modulation. We will never change these two constant parameters, right? In modulated signal, how the waveform is to be achieved means this is fully modulated signal. In this part is just by a modulator. This is a modulator, right? When the compression side is high means the modulator is achieved, right? Here from waveform. So suppressed and suppressed waveforms are available. Modulation index is expressed M is equal to EM by EC. Here M is equal to del by FM. Out of the sidebands available means only 2 sidebands are available. Here the infinite and depending upon the modulatum frequency is available. What are the bandwidth means? Here it is denoted as 2 FM. Here FM can have a narrow band and wide band, right? We are already discussed in the comparisons. So we, bandwidth is to be denoted as 2 into del plus FM of maximum. But the applications means here both has to be used for the broadcasting, right? But the audio broadcasting we are using the FM signals, and video transmissions we can using the AM signals. In FM signals there are 2 types of generation methods. So one is the direct method and second one is the indirect method. In direct method that is 2 types. One is the reactance modulator, another one is the varactor diode modulator. In the indirect method, Armstrong method. So what are the limitations? Here also we are having the limitations of direct method of FM generations. So what are the limitations means? Here having the oscillator, that is not a stable oscillator. We are using the one simple basic oscillator. What the oscillator generates means an oscillator always generates the carrier signal with high frequency carrier signals. This cannot be controlled. Okay, it is controlled only by modulating signal. So this is the limitations. Then next one, we can distorted FM due to non-linearity devices in the Baractor diode. This is also the limitations. Here, and what is the Armstrong method? How it works means, first one is the wise crystal oscillator generates the carrier signal, and the carrier signal is given to the buffer. Then carrier signal is also given to this in between the two combining network and buffer. In between we are also giving the carrier signal. Carrier signal is given to the 90-degree phase shifter. The phase shift output is given to the balance modulator. Where we are giving the input signal means audio frequency signal. Any of the audio signal is given to the audio equalizer. Audio equalizer is equalize these signals. That means when giving the input signal as low frequency, it converts the high frequency. When you are giving the high frequency as the input signal means it will be converted in the low frequency signal. So that modified equalizer signal is given to the balance modulator. Then balance modulator is balancing the carrier signal and also the input of AM signal is balance modulated these two signals and given to the combining networks. That sidebands only given to the combining networks. What the combining networks done means, here the output of the combining network is only narrow band frequency. So we cannot achieve the wideband signals without narrow band signals, right? So here the output of combining signal is narrow band signals. So NB narrow band frequency modulation as the output. So finally we are giving the very low carrier frequency, right? So we are giving the very low carrier frequency and modulating signals, right? So that is given to the multiplier. Here I will explain some of the examples, right? So first we achieve, then the output is, how could we multiply this, how could we multiply this input and the output is achieved by the high frequency means. Let us I explain. First the input, here he is having the two achieved inputs, right? So first one, we are giving the 75 kilohertz. Here we are giving the 75 kilohertz, but finally I have to achieve the 95 kilohertz means, how could I multiply here? Here I have to multiply 75 kilohertz, right? Here I am having the 90 kilohertz. By mixing carrier oscillator, okay, by mixing the carrier oscillator, here some of the frequencies I have to be mixed, right? So here I have given the 75 kilohertz in first group of multiplier. The output of this multiplier is achieved as the medium FC and low MF, right? So this output is mixed with the carrier, that means crystal oscillator. Crystal oscillator generates the carrier signal. So this could be mixed. Then the final output is also as low FC and FM. Then second group of multiplier is adder. So here also we can give some amount of frequencies, right? So this amount of frequencies also added. Finally we can achieve the high FC and FM. So for this purpose only we are using the multiplier as twice. So finally, depending upon our applications, class C, class B, class A, lots of types of power amplifiers are available. Depending upon applications, we can use the class C power amplifiers. Finally, we can achieve the high frequency FC, that means carrier signal, and modulating signals can achieve. Finally, it could be transmitted by using the transmitting antenna. So what are the, we are having some of the disadvantages are also available in the frequency modulation, right? So first one, the transmitted power remains to be a constant. This is one of the advantages, and we cannot mix any of the signals only because we are having only carrier signal and input signals only. That means audio signal and carrier signal only we are mixing every part, each and every part. We cannot mix any of the new signals, right? So this is one of the advantages, right? Next, here having some of disadvantages. What it means, too much occupied spectrum space and modulation index should be in low, as a minimized bandwidth should be used, and also we are having only very high frequencies. This is the Armstrong method is only used in very high frequencies because we are adding the frequencies. In first multiplier we are adding some amount of frequencies, and also here having the second time of crystal oscillator, that means second time of carrier frequency is added with the input signal, and also the second time of multiplier is added with the input signal. Okay, so two types of multipliers and two signals of carrier signals is added. For that we have to achieve and we have to use only at high frequencies, very high frequencies only we have used this FM modulation. So for what purpose we are using means radio broadcasting and sound transmission and police wireless systems, we can use this type of modulations. Then how could we demodulate these FM signals means here are two types of involved in demodulated signals. Okay, so first one what would be means slope demodulator. So here slope detector circuit is drawn here, right. So first one, the input signal is given to the modulator circuit. First one is T1 and the charging purpose we are giving three capacitors are added and one diode is to be added, finally load is here, right. So first one, here the input signal is given with low frequencies and high frequencies, right. So and here the transmitter signal is transmitted from the transmitter, that means T1 primary signal, and is to be as a suppressed and given to the diode, and the output of the diode is expressed in the load signal, that is the R1. So output is to be as 0, that is a low frequency. From this method we can achieve the slope detector. Then another method is Foster Seeley discriminator method. So discriminator, it is also to be as demodulator or detector. Okay. From this method we can give the input signal as a transformer, and the transformer transmitted the signal as high and low tuned circuits. Tuned circuits are also connected with the diodes T1 and T2. Then the envelope detector is circuit is to be connected. C1, C2, C3 and C4. 4 capacitors are connected here. This is to be as this circuit is to be mentioned as the envelope detector. So final output is to be achieved as K into X of T. Here the transfer characteristics is given when the frequency is increased. Here the positive frequency is increased means also negative frequency levels also increase. When the signal is increased from one part the another part, that means upper sideband and lower sideband DSB SC signals will be achieved in the transfer characteristics. Then what is the demodulation? Contains two tuning signals. There are two envelope detectors, right. Tuning signals means here the diode is connected with the capacitor. Here also one diode is connected with the capacitor, then also with the transformer. When this is connected, serial connected with the transformer, this is circuit is to be as a tuned circuit. One section of tuned circuit and envelope detector works for incoming frequency is greater than the carrier frequency, and also for incoming frequency is less than carrier frequency. Tuning circuits, what the tuning circuits do means it is converting the FM signal into AM signal and extracts the message from envelope detector. Then this is also another type of demodulator. This is a radio detector. This is also similar to the last method, that is Foster-Seeley method, right. Here what could we do means here only one device is to be connected in the reverse method, right. D1 is connected in the direct and D2 is connected in the reverse biased. Okay. So forward bias and reverse bias is changed here. So what it done means this noise is suppressed in this circuit. This is the main advantages. In this method the D1 and D2 is directly connected, that means that both diodes are connected in forward bias, but in this method D1 is connected in the forward bias and D2 is connected in the reverse bias, means here the RC filter what the output is getting means here the noise are suppressed in this circuit, that is to be mentioned as the potential divider circuit. Okay. This is the main advantage of radio detector. Then zero crossing demodulator, once we are giving the FM input signal, we are giving this is the FM input signal, here the suppressed and expands, right. So Hall limiter, this is to be as a pulse, we are giving this input as a pulse. Then zero detector, right, zero crossing detector is to be mentioned as a zero crossing detector. This level, then first the input signal is achieved in the positive, that means upper side band. Here the peak is to be in the upper side and here it is to be mentioned as 1 1. Here the levels is to be here, right. Then in this next waveform, next cycle, the positive signal is achieved this spacing only. Here it would be mentioned as the positive peak as pulse. then it is to be achieved as this lines only. Then negative is to be here. Then difference between these caps we are to be mentioned as a zero detector, that is high instant frequency in turns. It means the larger messages amplitude. Okay, messages, larger messages is the amplitude. This is achieved by the zero crossing demodulator. So demodulator means this is the hard limiter, that means two side independent clipper that is converted into FM signal into digital signal. Okay, stable mono vibrator is also connected. This the mono vibrator means 555 timer. Okay, so timer, what the timer generates means pulses with a constant amplitude and with spike in between the spikes. Here having the two spikes, right, that is to be mentioned as peak, right. Okay, these two spikes, in between these two spikes here they generate the constant amplitude and width, that is for that purpose only we are using the IC555 timer. Okay, so this is the main averaging a low pass filter circuit that integrates the pulse and generates the modulating signals. So frequency division multiplexing. So here how to multiply these signals means for allocation the different frequency bands or carrier frequencies into different channels, that is to be as a frequency division multiplexing. Also it is to be used in a transmitting radio and TV signals. Okay, so first we are having the 4 balance modulators. Okay, so balance modulator 1 and balance modulator 2 and balance modulator 3 and whatever how we can added a lot how much we want. Okay, so we can, this is the way as mentioned as balance modulator n. Okay, so here every balance modulator we have to give the carrier signal, right. Input signal is multiplied with the carrier signal, that only we can give transmitting the information from one part to another part, right. So finally these 4 outputs are given to the mixture or adder, okay, whatever. Okay, by combining these two signals, one type of component is to be added here. So from that component we can communicate this, we can transmit these signals from through the communication channel or by using the antenna. So how could be expressed these means? Always we know, last in first topic we can also discussed about the modulator is always used in the transformer, right. So different carrier signals are used in the stations, right. Carrier signals are depending upon the channels or stations. Okay, so different carrier signals are used depending upon the each and every balance modulators and every stations, right. So bandwidth of the FDM signals, that means frequency division multiplexing, is to be mentioned as the BWFDM is equal to narrow bandwidth plus n minus 1 bandwidth. Okay, number of channels, that is to be as a bandwidth of each channel and bandwidth of guard band, that BWG is mentioned as a bandwidth of guard band. Guard band is frequency gap between the two channels. When transmitter also having a channel and receiver also having a channel, these two types of channels is to be mentioned as the guard band. Here frequency division multiplexing, FDM demultiplexing. Okay, so how to demultiplex, that means how to demodulate these signals. The first one, we can transmit the signals, okay, by using the transmitter. Then we can achieve and also we can receive the signals by using the receiver, any type of the receiver or from receiving antenna. Okay, so from that we can receive some signals, okay, from the channel. Okay, so here we are using the band pass filter, that is to be denoted as BPF. Okay, band pass filter is used for the selected channels or stations. Okay, so band pass filters, because why we are using the filters? Filters are mainly used for removing the noises and also by adding the frequency levels. Okay, so depending upon the applications we can use the band pass filters. Okay, here we are using the band pass filters. This is a small diagram for a spectrum diagram. Okay, so individual channel is selected by the band pass filter, that is given to the demodulator. Okay, demodulator demodulate the signal, that means when we are giving the analog signals into digital signal, means digital signals are transmitted by using the channel and also received by the receiver and is transmitted from the demodulator. How the demodulator achieved means digital signals, but the original signal is analog signal. How could we achieve the original signal means by converting the digital signal into analog signal by using the demodulator circuit. Okay, from the demodulator the output list to be a signal 1, signal 2, that is channel 1, channel 2 we can achieve. So what are the types of noise? Some of the noises are we are already discussed noise, right? So what are the noises we can achieve? There are two types of noises. Noise means unwanted signals or any of the interference in modulating signals. Okay, any of lots of interferences available over the surroundings, right? So what are the interferences available means that is noise to be in two types, right? External and internal noises. Okay, so external noises means that is as atmospheric noise, industrial noise, extraterrestrial noise, that are the external noise. Okay, internal noise means thermal noise and short noise. When the circuit is overheated, when if you are using the one ICs means if when IC overheated, it will react some another form of actions. Okay, it will react when we are taking the readings means when the IC is overheated, the reading will be different. When we are giving the circuit connections on the spot, we can take the readings means the output will be difference from the after connecting, that means after overheated ICs the readings will be different from both the two ICs, right? So both the two readings the output will be different. Okay, so this type of noise also arrived, and also the surroundings, that means temperature also can be arrived, and also thermal noise and industrial noise, that is a manufacturing defect also to be mentioned as a noise. Okay, then atmospheric noise means the radio noise, that means the natural atmospheric surroundings and lightning, thunderings, also thunderstorms, these are the atmospheric noise. Extraterrestrial noise means radio disturbance from earth. Okay, so that is the external noise. Then there is a cosmic noise and solar noise, these are the extraterrestrial noise. Okay, industrial noise means motors, gears, fish, automatic ignition, building, these are the industrial noise. And short noise, thermal noise means that is to be a random motion of electrons. When we are using the semiconductor devices, the noise is generated from only short noise. Okay, and it is a thermal noise means it is thermal noise is always generated by using the resistors only. Okay, so that is denoted as Vn is equal to k T naught into Br. Okay, so what is the communication systems? Already last we can it's the first time we can discuss about the communication, right? Having one transmitter and finally having the receiver. In between this we are having a channel. These are the three components available for the communication systems. Okay, so by transmitting one information from one part to another part, we are using the communication, right? So we are using the three parts. Okay, three equipments we have to be used. First one is input signal is given to the modulator, and modulator having the carrier signal. This is achieved by the S of T. This is this whole connections are in the transmitter block only, and finally in channel block the output of the transmitter is given to the adder, and here having some noise is added. This noise output is given to the receiver block, one type of band pass filter. This is the channel block. From the receiver they can receive the with noise modulating signal and received by the band pass filter. Band pass filter removes the noise, and band pass filter will remove the noise, and when the input signal is in low frequency, it will convert it into high frequencies, that is given to the demodulator circuits. For what purpose of demodulator circuit we are using means when the signal is in a digital form, we can convert into analog form, because M of T is given as a digital form. Okay, so M of T is given as an analog format, we can receive the original signal. For that purpose only we are using the demodulator here. So finally the output will be achieved by the demodulator. Okay, this is the these are the overviews of communication systems. Thank you.